Okay, this is the first part of a re-gauging test. As in the very first film, we saw that we had a magnetic gate that would attract a rotor into it and keep it going through the entire flex gate. Problem is that while it's in the gate, it does not want to continue in this configuration to accelerate on its own or to really go on its own. However, I have found that it will in a circle design, but if I want to transfer this to a cylinder, which ultimately is what I want to do, it does not really want to appear to continue on its own. So there has to be another method to do that, and I think that we can do a re-gauging on this. Okay, here we can see that I've modified the acid ramp so that the actual metal and the flex gate is sloped up, but the surface at which it rides upon is actually flat. So this should allow it to be in a reverse V shape in order to climb this ramp. So it's actually going to climb the ramp, but it's actually going forward along a flat surface. Okay, here we can see that the flex gate works just the same as it did before. Going into it, crossing the entire gate, and went into the other. But what's more important here is that now, once we get it just on the inside, it'll actually continue to climb or roll forward on its own up this ramp. It's really going along a flat surface. And that's really important for the next part of re-gauging, because if this is in a cylinder, then we actually need to curve this flux gate inward as the rotor passes over it so that it has a chance to re-gauge. Okay, here we can see that we're set up for re-gauging. We've got two ramps identically the same, both going uphill, and that will allow us to cross over or re-gauge to the next one and again pull that rotor back up the next ramp. I think we could keep doing this over and over, re-gauging this way. So the top's not on it, the acrylic plate. Let me put that on it and let's run it and see what it does. Okay, here we can see that it'll actually climb the ramp on that side, and over here the same thing, it'll climb the ramp on that side with the re-gauging taking place in the middle. And it'll actually re-gauge and cross. It's actually climbing both of those now. One interesting phenomenon that I found out, though, is that if you push it back this way, it does not want to climb that ramp. Of course, it's trying to, climb it the other way. But for some reason, it actually wants to complete this process a little bit faster and better, even though it's being pushed back against that rotor. I might have to investigate that a little more. But nevertheless, it does climb the ramp. And I think that's what we need to make a cylindrical type motor that's permanent magnetic, is to be able to make and break this attraction here and be able to re-gauge it so that it can go up through the next step.